Hello and welcome to another video. Today we have a monster of a board. This is a Gigabyte X570S or Aorus. This thing is huge and really heavy, like actually enormous. And this board has a very interesting fault that I have had on different boards as well. Let's go under the microscope because it's very tiny. We're going to be looking at the area right here left to the PCIe slot. And what we can see here is a lot of damaged and burned components, as you can see here on the left side. And I've taken a sneak peek into the board view to see what this area is responsible for. And this area is responsible for LED lights. This is for the RGB headers to send out some signal into maybe this on the left right here, this display here, and maybe responsible for some of the RGB headers that we have right here. And this, I have seen this kind of damage multiple times, where someone has plugged in RGB components the wrong way. Don't know what exactly it was, but I've seen this multiple times where this blows up. And I would expect that we have low resistance on 3.3 volts. There might be a Aorus chip, it's called, I think, that is responsible for RGB, that is on the 3.3 volt line and maybe even on the 5 volt line and is shorting that to ground. So let's right now see if we have lower resistance on our 3.3 volt line. So this should be right here. And I think I'm not getting good ground. And now I found a good ground. And we have low resistance on 3.3 volt, as I expected. So this is, what, about 30, 40, 50 ohms. So very low. I think this might be, somewhere around here might be 12 volts. This looks like a very similar resistance. Or that might have been 5 volts. So I think the 5 volts and the 3.3 volts has a problem because of probably the controller. Yeah, and this has 30 ohms. So I think the 5 volts and the 3.3 volts is shorted. So we're not going to be connecting anything right now, but I will have to take all of this off, this giant heatsink and giant shrouding, because I expect the controller to be somewhere in this area. So let me quickly do that, and then we will see each other again. So now the board is stripped down. And the thing right now is I do not know how to remove these M.2 back ends, like the lower parts of them. I don't see obvious screw and no screws at the back for them here. So I don't know how these are taken off. They might be, I might need to take these ones out, like these standoffs, to get them off. But we will see if we can do everything we need by just doing that. I will though have to remove this one in addition for us to be able to work in that area. I have removed the shrouding and look at what it has revealed. So there's a lot more damage to the circuit board than I imagined there to be. Let me get this in focus. So this reminds me an awful lot of the board that we had where the VRM was blown. So this must have been a 12 volt short, and quite massive one. We will be starting by removing components. So what we definitely need to do is we will need to remove these two transistors, whatever is left in between there, and then I will start picking away at this and I will see how much comes off, because as you can see, this is just flaking off right here. Yeah, and all of this on the left side as well. All of this masking is just dead. Just flaking off. This is going to be an interesting one. So this area must have gotten so insanely hot when this happened. This must have smoked really badly. But I think what I'm taking off right now is actually just paint, because you can see the actual circuit board under here, and this looks like it is fine. So this would be great. I think I'm only removing paint right here, like the black solder mask of it, and not actually removing the masking that is on the traces, because as you can see right here, there's still this trace here and it is not burned. But this here is worse. Yeah, here you can see, here it starts, the layers of the board start to deteriorate here. This is the fiberglass of the board. And yeah, you can see this just coming off completely. These were components. Yeah, and this is burned here. So let's apply some solder to these. So now let's get some flux in here. Flux this up. Now we take our solder. Using our soldering iron, we're going to apply some leaded solder to these pads, to these legs. Now we have a good amount of solder on these pads, except this top one did not seem to get solder onto here, and now I did. And this already wants to come off, as you can see. Yeah, there it is. So this came off just by soldering. And the other one we will have to take off with hot air, because the pads seem better there. Still seems to be attached there, but it has to go as well. And this smells awful. Like when heating this place up, it smells awfully burned. Come on now. Now it let go. So that transistor might actually be good, to be perfectly honest. But we're going to remove it anyways, because I don't want to confirm that yet. And I want to clean this place up a little bit more. The big question now is how we're going to proceed. Let's try to take this fiberglass layer off of here and see what is under there, if we need to continue to Dremel something out there or not. I hate this fiberglass stuff. It's so annoying to work with. Way too fuzzy. Let's try to remove it. So it seems to be there's a big ground layer under this, and there's not more fiberglass. So we probably will have to see that none of what was left over here is shorted to that ground layer. We will have to check the resistance if anything has changed. And now let's take some cotton buds. Let's clean this area up a little bit so we can see better. So this is a lot of the fiberglassing already removed from this layer. And I think this top part, these resistors here are load resistors on the 12 volt side. And I think these only got charred, but I don't think that there's a problem with them. There's a lot here. So this area right at the bottom here cleans up very good. So this was just a little bit of charring. If you can see how the cotton bud now looks. But it's cleaning up a lot better than I thought. So now I think we can assess the situation a little bit better. So all of this down here is fine. None of this has any damage. So we're starting right here with kind of a different section that is starting about here. And all of this is fiberglassing. So this is one via here. There might be a problem. So we need to make sure that there's nothing shorted in here. And this seems like the biggest point where there might have been the actual short circuit happening, or the supply that was shorted, because this has the most charring in it. And I would expect that we need to clean this up, whatever this is here. This might be fine. This is also a via right here. This via probably connected to some of these points. Then there's also this, which also is one side of the pad for the transistor. This looks fine. I don't think there's any more charring or any more shorting right here. And the pad that was here for the transistor is completely gone. One question remains if this is 12 volts here and this is still getting here or not. And another question remains is how do our voltage, does our resistances look like? So I'm going to be using a multimeter, and I want to show you where I'm going to probe on, and I'm going to tell you what I get as a reading. So let's now go onto this pad right here. This seems to be indefinite, so OL. So let's see here, this pad. And this might be ground. This has 0 ohms. This pad right here has 1.6 mega ohms, so that is fine. Let's see here. This has 137 ohms. This might be fine. This might not be. And this pad right here has the same 137 ohms. So let's see if I can get this via. This via shows 0 ohms, so that might be a problem. This also shows 0 ohms, that one. And this might be a ground layer right here. So we probably will have to Dremel at this point further. But I want to see the actual voltages of the incoming ATX connector, the 24 pin. Let's see for that. So the resistance for 12 volts should be this one. And let's see. This resistance looks fine. This has very high resistance even. Might be too high. So let's further see. For example, for 3.3 volts. It is the one on the bottom left. So we now have higher resistance here, as you can see. Before we had a lower one. This now has kilo ohms. Oh, let me get a better ground. And let's confirm that once more. Come on, man. Get me a good connection on this. This has about 150, it just showed. So I still think there might be something wrong with our 3.3 volt line. I don't think that is fixed yet. Let's go to 5 volts and see for that. Let's go into this ground again. 5 volts should be here. And this looks very similar. Oh, well, maybe this might be fine. But it has weird readings. So I don't trust those lines yet. So what we will do instead of just connecting the ATX24 pin is we will supply our own voltages to this board. So we will be using our lab bench power supply, and we're going to be injecting first 3.3 volts and later then 5 volts to see how much current these lines draw and see if that is correct or not. And right now we have 3.3 volts. I have ground connected, and let's now probe 3.3 volts and see how it reacts. And this looks too high. Like, this has about an amp, which I wouldn't expect. So I think an amp is too much of power consumption. And especially because this power consumption is jumping like that, I think that is still too much. Let's see for the 5 volts how this reacts. Yeah, the 5 volts has a massive short on it. That just drew a lot of amps. So let's see that for one more time. Look at the power consumption of 5 volts. This has about 5 amps. And the area gets hot in which we were right here. And I don't know if you can see that, but it even sparks. Interestingly enough, these LEDs come to light for a very faint time. Let's see. I'm gonna get the microscope in, and maybe you can see the sparks that I actually created. We drew that much current. Maybe you saw that right there. But there is a lot of current going into this board. Like an awful amount of current. So I think it's the center pad that we saw before that is drawing this amount of current. So we will have to keep dremeling at that away to see if we can remove that short circuit. So the center pad was getting very hot. Let's see now. I might want to try to first go at it a little bit with my tweezers. See if I can dig it out, and if not, we might need to get the Dremel. So what I think is that we have a big ground plane right here, and it somewhere still connects to it. So if we take this off here, we can see a lot more charring that still has happened. Oh yeah, there's a lot more to unveil here. Oh yeah. Great. Just tearing up this ground layer, but just pulling it off here. It's this chart, and we can just pause for you out of the way so you can see this better. Like, I need for you to understand, there is some force in this of pulling this off, but it is way easier than you would expect for actual copper to come off of here. So I think right there we are good. Everything that is going like right there. But all of this, as you can see, this is all still charred. So let's scrape just a little bit with my tweezers, see where we will get, and clean this up afterwards. Yeah, I think right here in the middle. This is the point where most of the damage has happened, and all of the rest on the other side, like around it, is just collateral damage. I will have to think how to remove these copper lines here, like the grounds, because tearing them off here was easy because they were burnt, but here there's healthy pad, and getting off of there is basically impossible. Probably have to cut it off or Dremel it off. So let me quickly dump all of this mess off of here. Literally, I'm going to take the board and dump this over the trash can. Looks very interesting already. Let's get some IPA into here. And let's clean this up and see if we can better decide what is happening here. So this shows better and better how this is built up. So we can see we've removed a whole layer above it, and that I think was a ground layer. And the next layer right here might also be a ground layer that we can see. And we can very well see that this one via that is going down, everything around is charred in this place around it. So this is where the biggest short circuit has happened. Interesting that this chart also here. But I think we will have to focus on this area right here, because I don't think that we're getting any short from here. We might get a short from this via, and I think it was this via, but I would mainly focus on this one, because this is where it all wraps around. Oh yeah, oh boy. And the next layer just comes off just like the previous one. Oh man. Oh well. Great. This layer even comes off easier than the one that was above. So this probably got even hotter in there. Like this layer, these layers just tear off so easily. Oh man. Like, don't get me wrong, I have still hope for this mainboard, because this was like, this is not a VRM issue like we had before on the ASRock board, where there was the area shorted responsible for powering the CPU. And this time it's just areas supposed to be connecting LEDs. So I still have a lot more hope for this board. But seeing the original picture that we had, I wouldn't have imagined that this goes that deep. Like, something shorted around LEDs, I wouldn't expect it to burn this badly into the board. But I can definitely say this must have been a 12-volt short, where there was a lot of amps going into this. And I cannot seem to find the VR. Ah, there it is. There's the VR that we've seen before. That was probably shorting. So let's now take cotton buds again and clean this area out. I'm using so many cotton buds right here. There's just so much to take off here. So as deep as we go, the better we can see where the damage occurred, and we still can see some leftover of the via right there, of the copper line, and that this area, for example, has been good. There was nothing here, but it has actually burned here and was here, and might have also gotten this via right here. So we still have to see if we can clean this one here up and see that this isn't shorted to anything anymore. Maybe peel off the copper around it. That is, for example, here. But I will probably have to get bigger tweezers because I'm using fine tweezers right now. And some of these copper traces are connected better than I thought and need a little bit more persuasion to be pulled off right here. And this starts to be really difficult to remove. So I believe that there's nothing problematic here anymore. So the burn doesn't seem to get, yeah, this is now healthy. This is good because we want to get as far as to the point where we don't see any physical damage anymore, or like any burnt damage anymore. So this area is still a little bit charred. You can see here. So I really have to pry at this to remove this copper, but we have to do that to be sure that it is good. Because if it removes easily, like the way that most of this does, it still isn't good. But I think we've cleared the short around here. There should be, I think, 12 volts coming into here, and that might be something that we will have to re-establish. So with now a lot more removed, let's see for the voltages how they behave, and inject some power into here again and see if we have any difference from before. We have 5 volts again. We mostly need to look at the power supply. I don't think that there will anything be here. And as we can see, we still have way too much of power consumption, so we have 3.3 volts, 3.3 amps. But I cannot feel any heat here anymore. So it doesn't seem to be in this area anymore, where the short is. The next thing that we might have to do is we might have to find the controller that was responsible for the LEDs. So for this now we have to go to our board view and have a look at our damaged area. So right now we are on our board view, and the damaged area is this one right here. So you can see on this ones there's 12 volts on this side, and it's going through to here, and there is a transistor, I think this is. Let's see, this only connects to these 2 points, and this connects to all of these, and the other side of this is IOGP. Oh, this connects to IOSIO. That is not good. That is really not good if that connects to our SIO. Okay, so we have one more thing to check, definitely. Check the SIO. And this one is VCC3. So this is our 3 volts that is coming from the ATX power supply. That might be still shorting through here. This was the LED area that I originally was talking about. But it seems that our short didn't happen on the LED side, but on our 3.3 volts side, somewhere with the SIO. Very interesting. So let's still see where that controller is for these LEDs. So I think it should be from this. Ah, there's our controller. So this thing probably controls our LEDs, and we will have to take a look at that also, if that might be shorted. And this is just a 20 ohm resistor, and then goes to the LEDs. So I think we will take a look at this controller right here, and we will have to take a look at our SIO, how this one behaves. So let's go back to the board and see for that. So our SIO doesn't look damaged, but it doesn't have to mean that it is not damaged. So what we're going to do is we're going to be looking for some resistances around it. And for this, I always just choose resistors, big capacitors around it. Like for example this one. And this has 230 ohms, which I think is good. So the dedicated 3-volt line for the SIO seems to be fine, but there might be a short on it on the 3-volt line. So this capacitor also has high resistance. This has high resistance as well, so I think this is fine. And this also has high resistance. So I think the big crisis of our SIO, that could be that is not the case. So next I will have to figure out how to take these M.2 covers off, because if you see in the overview, our chip that we saw for the LEDs sits right down here somewhere, and I cannot see it like this. So I will have to figure out how to remove this, and then we can look at the components under that. I've managed to remove the covers for the M.2, and as we can see right here, this is our chip. So the chip itself looks very fine. Nothing around here looks burnt or anything. So we will still have to find out if this chip is shorted. For that, we use that capacitor that you can see on the bottom left. Let's connect to ground. Let's connect to this side of the capacitor. And that shows 270 ohms. So I think that is fine. That is not shorted anymore. And now the big question remains, what kind of pads are here? So what is there left from here? For this, I will be using continuity mode, and I will be trying to connect off to whatever is left here. So for example, to this copper here, and see, does this connect to ground? So whatever this is has 230 ohms to ground. And this is our 3.3 volt line right here. Because what I'm doing right now, I am probing this little piece and probing the 3.3 volt line in the ATX, and I have 0 ohms. So we know this small thing here is the 3.3 volt line. So let's check if we can see what this thing here is. So this is still connected to ground. This has like 10 ohms to ground. So this might be a place where we still have to go on and have to see if we need to Dremel away with that. So let's get this a little bit out of here, because we don't need this for now. Let's connect to this plane right here. And this seems to be ground. This has 0 ohms to ground. And let's connect to this copper here and see to ground. And to ground, this has 1.5 kilo ohms and rising. This looks good. And let's see if this is 12 volts. Yeah, and this is 12 volts. This has 0 ohms to 12 volts. So we now were able to establish that this layer right here seems to be ground. This dot here is a 3.3 volt layer. This is 12 volts. And this might be ground as well, and might be our still remaining problem if this is not ground. So let's now see again what kind of power consumption we will have on the 5 volts if we still have that much. And we still have 3 amps. And I cannot feel anything that might be shorted here. So, because I cannot figure out what the problem for the 5 volt is, I will be attaching a wire to that 5 volt, going to be applying the voltage to it, and I will take out my thermal camera and I will have a look around the area if I can find where the problem is. I think I found the shorted component that is having the problem right now. And let's see now. So pay attention to the screen, even though it's a little bit hard to see. But we're currently looking at this area of the board. So, and let's see now. We have 150 degrees right there. And there's a single chip here. And it lights up like a Christmas tree to hundreds of degrees. So the chip that we were seeing was this one right here, which is that one. And it doesn't look physically damaged or anything, but it seems to be shorted internally. So let's go onto the board view again and see what that thing is responsible for. So this thing seems to be taking 5 volts dual and applying it to the USB-C connector right here. Interesting. So I wouldn't have expected anything here to be damaged like that. But let's get that component off and see how our 5 volt rail behaves afterwards. And now the chip is removed. The capacitor right to the side is still there. It just stood up. So, and let's now get our power supply in here again. And let's see how our 5 volts has changed in power consumption. So let's turn our power supply on. And let's now see. And we still have way too high. So we still have 2 volts, 2 amps of current draw. We definitely have removed some of the short, but not all of it. So I will be getting my thermal camera out again and do the same thing once more. So I was able to determine another point of failure, which is probably our audio C, right next to the area where we've been working on. So this is at 62 degrees. This should not be like it is. So just for you to see, this is this IC right there. And let me remove that, and then we will see how our 5 volt behaves. And now our chip is removed. Let's now see. We have 5 volts again. And we still have too much. We still have 1.5 amps of power consumption. So there is still something wrong. I will get under the thermal camera again and see for the next component. So this seems to be the exact 2 chips that we had before. So these look similar to the one that we removed close to the USB-C chip. And it's probably both of them that both are dead. So we're going to be taking off both of them, and then we will see how our power consumption will look out, after that. And now both of these chips are removed, and let's do the power consumption test again. So now let's see. So our power consumption looks a lot better now. We have 430 milliamps, but I'm still not sure if that is correct because none of the LEDs are lighting up here anymore. And I think at least some of them should be lighting up. Just like on the 5 VSB, they're not lighting up. So there might still be something wrong with this board. But I think we are at the point where I would want to connect the my power supply. And we're going to see how this board will react to that. So let's now see. Let's get this connected onto here. And now I'm very interested how this will behave. Interesting. So we have 200 milliamps of power consumption. And I think that is not right because our LEDs came on for a very brief second and then turned off again. So I believe there still might be something wrong here. But I want to see if this has any reaction to the power button or not. So we're going to be taking the 3000G in here. Let's put this into here. And let's get 1 stick of RAM and get my DDR tester to see if there will be any postcodes, or might even use this for PCIe. And let's see now if there's any reaction to our power button here. There actually is reaction to the power button, and we cycle DRAM and we go to VGA. I cannot believe this. Okay, I think we're at a point where this might be posting. Let's quickly test this out. So we have the 2200G in here, and now the LEDs even stay on. Very interesting. Let's get HDMI onto here so that we can get a post and get the post scrolling on here. And let's try this again. So let's see. The power consumption, I gotta say, looks very healthy. Like it boots up, it goes up to a point where I would expect it. And now we are at VGA, and let's see if we can get, yes, there it is. This board is posting again. We have a posting board after all of that damage what we've just seen. Cannot believe it. You still can see the crater right down here. And there is the actual BIOS. I cannot believe this, that this actually went so far. So let's now see what actually is missing on this board. Because I have moved many components for this board to turn on and not have a short circuit anymore. So let's go on to the board view and see what kind of features we would be missing now. So looking at the board view, the first thing that is obvious is we won't have any audio anymore. So none of this audio is going to work. So we don't have onboard audio. I think it might be actually just changing out the chip and that will be it. But there might also be more problems connected to it. So there might have you might have to connect a PCIe to audio card in order to have any more audio. The other two things that we've removed were these ones. So this would be interesting to find out what this is responsible for. Like, these are its inputs, enable, and this might be its output. And this is an S-media chip. So this might be related to some kind of USB. Yeah, this is related to USB, to this one here. To the USB-C. Oh, so these are USB-C controllers, just like we had before, and this one died. And let's see what this one is responsible for. Status indicator, Vcon, 3-volt dual. So this thing might not be damaged that were removed. It might have been the other one that is only damaged. Oh no, it is also connected to the USB-C at one point. So this is also damaged. Yeah. So what we won't have is this USB-C. We won't have this USB-C, and we won't have audio. The next big question is whether we have working USB ports at all, and whether we have working Ethernet. So these are the next two things that we need to find out if those are working on our board or not. Let's now boot the board up. I have an M.2 connected to here. And let's see if we can get into Windows. And what I want to do is I want to put a small heatsink onto our PCH to have at least something on here to dissipate the heat. And let's see now if we can get into Windows and test, for example, these USB ports. Interestingly enough, we still have LEDs here. I think they might not have the right color because one of the colors was one of the transistors that we removed. But these still seem to work. Let's get our pause screen onto here. And we're currently booting into Windows. Let's see, this heatsink is getting hot. So I might have to, I will have to turn this off immediately and put the actual heatsink on here for the PCH. So let's turn this off because the PCH is getting very hot and I don't want that. Please turn off. And there it's turned off. So I'm gonna get the heatsink for the PCH at least reassembled, and then we can continue with the testing. I've not removed anything around the PCH area, so that one can even stay on because the only part is there, and right here where we removed something. So let me quickly do that. And now it's reassembled. So let's do this again of turning our board on. So we're already in Windows. And now, first thing I want to do is check all the USB ports, all of the other ones. So this one works fine. So I'm plugging in the keyboard on and off. So you can see this one works. Go to the next one. Expect this one also. Yeah, this works. Let's go to this one. This one also works. This is above the USB-C. So the USB-C is not going to be working. So let's plug into the next one right here. This one is working. I can't test the next one down under it because of the HDMI adapter that I'm using. But going into this one works fine as well. This one works fine. And there's 4 more here. Wow, this has a lot of I/O. This seems to be working. This one is working. So all of these are working, pretty sure. So let's get the mouse onto here because I want to see if the wireless is working on this. So for this, let's get our post screen and let's make it a little bit bigger. And it seems to be not working right now. So that might be a driver issue. That might be related to anything like that. But let's first try the Ethernet, if that will work. So our Ethernet is also working. That is a very good sign. So next off, I would want to test if all 4 slots are recognized of RAM. So let's try that next. And now with all 4 DIMMs installed, we are posting, which is very nice to see. So now I will see if there's any drivers to install in order to get the Wi-Fi module working. And I will be working on that. One moment, please. And now after I've installed drivers, we now can see that not Ethernet, but the Wi-Fi is also working on this board. So this was only a driver thing. And now we're running with our big GPU installed in here. So the PCIe is also working. The M.2 is working because our Windows is off of that. And yeah, I'm going to be doing some stress tests on here. And yes, I can leave the VRM off because this is a very low power CPU and this is such a beefy VRM. It will not care if it's not cooled because it can supply so much power to it. So that won't be a problem. I will be testing the GPU and I will be testing the data lines that is connected via 16X, that all of that is working fine and that the CPU is running stable in this one. And then the big question remains what to do with this board. So the thing is that right now we're missing USB-C right here. We're missing USB-C right there. And we're missing the audio on the bottom left right here. For this to be a good board, I would at least solder a new chip for the audio onto here. I really don't care about the USB-C. I have never used USB-C on my computer before. And even if I would want to, there's really not too much to it to solder these two chips back onto there, or to get two new chips and solder them back onto there. So I will definitely order up an audio chip and solder it into there, and that will be probably everything that we need in order to get the audio working onto here. But I will probably won't order these two USB-C chips. I don't think that it makes sense to sell this board, because of the enormous crater that we have down here with all the layers that were burned. I think the only functionality that we have lost is some of the RGB, which I frankly really don't care about. And the rest seems to be intact there. We were very lucky that it was in an area where there's not important stuff there at all. So I'm very happy for that this now works. And I'm going to be ordering an audio IC, or I'm going to be looking if I have any in my stash, but I don't think I have, because the boards that I have are not as high end as this one. So I'll probably have to order that one, and I will be leaving out the USB-C. And this board might become my main driver in my computer, because I have the 5800 X3D, and I think this would be a very nice matching combo for it. And I really don't want to sell this board to any customer and give it to them. So thank you very much for watching. I hope you enjoyed this repair. Hope you learned something. One more thing I want to say is I think some higher voltage got on the 5-volt lines, and the controllers that we've removed have taken the hit for that. So this is, I think, what happened on this board. How 12-volt got into there, I have no idea. Something has been shorted, something was wrong, but the board is working now again, and that is the most important thing for me. I hope you learned something. Thank you very much for watching. This has been Mainboard Medic. Thank you very much, and goodbye.